Welcome to Part 2, Teams and Roles. Scrum is not only about meetings, backlogs, and sprints. It is primarily about people working together with clear responsibilities, shared goals, and collective ownership. Successful Agile teams understand who makes product decisions, who supports the Scrum process, who delivers the work, and how supporting functions contribute without disrupting team ownership. In this part, we will explore how different roles collaborate, communicate, resolve challenges, and remain accountable for delivering valuable and high-quality outcomes. We will also look at how engineering leadership and organizational governance can support Scrum teams while preserving self-management and agility. Let us begin by understanding the people who make Scrum work. Welcome to Part 2, Teams and Roles. First, we will introduce the Scrum team and understand how people work together toward a shared goal. Second, product ownership explains how product direction, priorities, and value are guided. Third, Scrum leadership then focuses on supporting the team, enabling collaboration, and strengthening agile ways of working. Fourth, engineering accountability highlights the shared responsibility for planning, quality, execution, and delivery. Finally, Agile governance explains how engineering leaders, project teams, quality functions, and management support the Scrum team without weakening its ownership. Together, these topics show how clear roles and effective collaboration create strong, accountable, and high-performing teams. Let's start with the Scrum team. This image introduces the Scrum team as one small, focused, and accountable unit. At the center is the shared product goal, which gives the entire team a common direction. Around this goal are the product owner, the Scrum master, and the developers. The product owner guides productivities and value, while the Scrum master helps the team work effectively within the Scrum framework. The developers bring together mechanical, electrical, electronics, software, and design capabilities to create a usable product increment. Together, these roles form one Scrum team. The Scrum team is the basic working unit in Scrum. It is not a reporting structure or a collection of separate departments. It is a delivery team that collaborates, solves problems, maintains quality, and works toward the same product goal. Success belongs to the entire team, creating shared ownership and collective accountability for delivery. The product owner provides direction and maximizes value in vehicle development. On the left, customers, business teams, engineers, and safety specialists provide needs, feedback, technical inputs, and compliance expectations. The product owner brings these different perspectives together and helps the team understand what should be developed and why it is important. The product owner prioritizes and continuously refines the product backlog, ensuring that the most valuable work is addressed first. This requires balancing customer needs, engineering capabilities, safety expectations, regulatory requirements, and business value. The objective is not simply to complete more tasks, but to guide the team toward a safe, sustainable, high-performing, and valuable vehicle outcome. The Scrum Master enables the team to work effectively and maintain steady progress. The Scrum Master helps the team follow Scrum properly by facilitating discussions, coaching team members, and improving collaboration. Along the engineering path, teams may face impediments, process gaps, communication issues, dependencies, and distractions. The Scrum Master works with the team and the organization to identify and remove these obstacles before they slow down engineering delivery. The role also protects the sprint from unnecessary disruption while helping mechanical, electrical, electronics, software, and design engineers remain focused on their shared work. By clearing the path and empowering the team, the Scrum Master supports steady progress, quality delivery, customer value, and achievement of the sprint goal. The developers or engineers form the cross-functional engineering team responsible for turning ideas and priorities into a usable product increment. In vehicle development, many forms of engineering are required to come together. Mechanical engineers design and validate the vehicle structure and mechanical systems. Electronics engineers develop the power systems, wiring, controllers, sensors, and embedded hardware. Software engineers create and test the control, communication, and application functions. Industrial design engineers support concepts, 3D models, usability, and design for ergonomics. These engineers do not operate as isolated departments during the sprint. They plan the work together, solve integration problems, maintain quality, and share responsibility for delivery. The result is one team working toward one goal and one valuable increment. Now that we have completed the Scrum team, let us move to product ownership. In this topic, we will understand how product direction, priorities, stakeholder needs, and value are guided throughout development. Let us now explore the role of product ownership in building the right product. Let us see how the product owner manages and prioritizes the product backlog to maximize product value. The backlog contains everything the team may need to build, improve, fix, or validate. The product owner continuously orders these items from high priority to low priority based on customer value, urgency, risk, technical impact, and business need. Stakeholders and engineers provide important input, but the product owner maintains clarity on what should be addressed first. In our engineering setup, department heads typically perform the product owner role for their respective areas. They work with engineers and stakeholders to understand requirements, dependencies, effort, and expected outcomes. The objective is not simply to create a long list of tasks. It is to ensure that the most valuable work rises to the top of the product backlog and receives the team's attention first. Product ownership begins with understanding the customer need and the outcome the product must achieve. The product owner translates this need into clear product direction and an ordered product backlog. However, product ownership is not just requirement writing. It is about ensuring that the engineering team works on the most valuable and relevant problems. The product owner explains what is important and why it matters, while the Scrum team determines how the solution should be developed. Cross-functional engineers from mechanical, electrical, electronics, software, and design then collaborate to create the solution. Their work produces a product increment, such as an improved battery module, drive system, vehicle dashboard, or functional prototype. This flow connects the right customer problem to the right engineering solution, resulting in maximum product value. The journey begins with the product vision, which describes the long-term direction and the broader outcome the product should achieve. For a development program, this vision could be to create a safe, reliable, efficient, and customer-focused vehicle platform. However, a broad vision is not specific enough to guide immediate engineering decisions. The product owner therefore converts this product intent into a clear product goal. The product goal defines the most important product outcome the Scrum team should work toward next. The team then creates a sprint goal that identifies the specific objective for the current sprint. Mechanical, electronics, software, and design engineers collaborate to achieve this objective. Their combined work produces a usable increment, such as an improved battery system, vehicle control feature, or validated prototype. This roadmap shows how the product owner converts vision into focus, focus into execution, and execution into measurable product value. Backlog ownership begins by collecting inputs from customers, engineers, testing, safety, compliance, and field operations. These inputs may include new ideas, defects, technical risks, improvement opportunities, and changing customer needs. The product owner reviews these inputs and orders the product backlog according to product value, urgency, risk, and alignment with the product goal. However, the product owner does not create every technical detail alone. Engineers help clarify technical feasibility, subsystem dependencies, safety concerns, development risks, and the effort required to complete the work. For example, a battery feature may depend on electronics, embedded software, thermal design, vehicle controls, and validation activities. This engineering input helps the product owner make informed prioritization decisions. During sprint planning, the Scrum team reviews the highest priority items and selects work that supports the sprint goal. The result is a clear flow from many competing inputs to an ordered backlog and a realistic sprint plan. Here we see how the product owner balances multiple stakeholder needs to maximize product value. The first consideration is customer need, which defines the problem the vehicle must solve and the outcome expected by its users. Engineering feasibility confirms whether the proposed solution can be developed within available technology, resources, dependencies, and time. Safety and compliance ensure that the product protects users and meets the required engineering standards and regulations. Business value considers whether the investment supports product strategy, customer adoption, and sustainable delivery. In a product development program, value is not only about vehicle speed or adding more features. Value also includes reliability, safety, maintainability, manufacturability, and field readiness. The product owner works with customers, engineers, quality teams, and business stakeholders to understand these competing needs. The product owner then makes transparent trade-offs and orders the product backlog to achieve the best overall product outcome. Effective product ownership means balancing needs, making informed decisions, and maximizing value across the complete product lifecycle. Now that we have completed product ownership, let us move to Scrum leadership. In this topic, we will understand how leadership enables collaboration, supports the team, removes obstacles, and strengthens effective Agile ways of working. Let us now explore how Scrum leadership helps teams perform with confidence and focus. The Scrum Master is at the center of team execution, helping everyone stay aligned and effective. In our engineering setup, team leads typically take on the Scrum Master role because they understand the team, the technical context, and the delivery challenges. The Scrum Master guides the team through the sprint backlog, coaches better ways of working, and keeps everyone focused on the sprint objective. They also help remove blockers, resolve coordination issues, and ensure different engineering disciplines work together rather than in isolation. The role is not about micromanaging every task. It is about providing direction, coaching, alignment, and support so the team can make good decisions and deliver the increment successfully. Here we understand what Scrum leadership means in practice. At the center is the Scrum Master, whose role is to enable the team rather than control the team. The surrounding actions show the core of Scrum leadership: facilitate, coach, remove obstacles, and improve. Facilitation helps the team communicate clearly and work together effectively. Coaching helps the team develop better habits, stronger collaboration, and greater self-management. Removing obstacles helps protect progress when teams face blockers that slow delivery. Improvement ensures that the team keeps learning and becomes more effective over time. At the bottom, the Scrum team is shown moving together toward the sprint goal through planning, collaboration, and delivery. Overall, the image shows that Scrum leadership is about creating the right environment for engineers to succeed together. Here we see how Scrum leadership, who is your team lead, helps the team stay focused on the sprint goal by removing impediments and protecting delivery flow. The engineering team is moving together toward a clear outcome, which in this example is an EV thermal management prototype. Along the road, several common blockers appear, including dependency, approval delay, test rig unavailable, supplier issue, and priority change. At the center of the action is the Scrum Master, who helps clear these obstacles so the team can continue working effectively. This does not mean doing the engineering work for the team, but enabling the team to maintain focus, flow, and momentum. The image also highlights an important leadership idea: protect the sprint from unnecessary disruption while keeping everyone aligned to the sprint goal. In short, Scrum leadership helps the team move from blockers to progress and from progress to delivery. Now that we have completed Scrum leadership, let us move to engineering accountability. In this topic, we will understand how engineers take shared responsibility for planning, quality, collaboration, execution, and delivery. Let us now explore how engineering accountability strengthens team ownership and dependable outcomes. Engineering accountability is the shared ownership of delivery across the complete Scrum team. At the center is a product increment, representing the usable outcome the team must deliver together. Mechanical engineering contributes design, suspension, and transmission. Electrical engineering contributes motors, batteries, and harnesses, while electronics brings sensors, communications, and autonomy. Software contributes web, mobile, and embedded systems, while design supports industrial design, user experience, and communication. Each discipline has specialist responsibilities, but none works in isolation. The key principle is one sprint goal, one team, and one increment. Engineering accountability therefore means moving beyond individual tasks and taking collective responsibility for integration, quality, and successful product delivery. Let us understand how a sprint goal is converted into a usable product increment through coordinated engineering work. The sprint goal defines the outcome the team is trying to achieve. Developers then create and continuously adapt the sprint backlog to determine how that goal will be delivered. In EV development, a sprint goal could be to demonstrate reliable, low-speed vehicle movement. Achieving this may require mechanical drivetrain readiness, motor controller integration, power harness completion, vehicle control software, diagnostics, and operator interface updates. These are not independent deliverables. Mechanical, electrical, electronics, software, and design work must come together through integration and validation. Only when the complete system works together do we create a usable product increment. The flow is simple: goal, plan, build, integrate, and deliver. The sprint backlog is not a document that is frozen after sprint planning. Developers continuously update it as they learn more about the work during the sprint. For example, software integration may reveal a missing signal from the electronics controller. A mechanical packaging issue may require the electrical harness to be rerouted. A test result may also create additional validation work that was not visible earlier. The team should make these changes visible, discuss cross-functional dependencies, and adapt the plan together. The key behavior is transparency. Problems, risks, and dependencies should become visible early enough for the team to respond effectively. That is why the cycle of plan, build, integrate, review, and update continues throughout the sprint. An important principle of engineering accountability: quality is a team responsibility. Quality should not be treated as something another department checks after engineering has finished. Engineers or developers are accountable for creating work that meets the agreed definition of done. This can include design reviews, code reviews, testing, documentation, interface verification, safety checks, and subsystem integration. In an EV system, failures frequently occur at the interfaces between subsystems. A motor may work correctly, and the controller may also work correctly, but the integrated propulsion system can still fail. The cause may be communications, power delivery, thermal behavior, timing, configuration, or another system dependency. That is why mechanical, electrical, electronics, software, and design teams must collaborate throughout development rather than working independently. Peer reviews and cross-functional ownership help identify problems before they become integration failures. The strongest engineering teams do not stop by saying, "My component works." They ask the more important question: does the complete increment work? That is the difference between completing individual tasks and delivering a usable, integrated, and high-quality product. Now that we have completed engineering accountability, let us move to Agile governance. In this topic, we will understand how leadership, systems engineering, quality, verification, supply chain, and management support the Scrum team. Let us now explore how governance can provide direction and oversight without weakening team ownership. Agile does not mean that every team operates without organizational controls. As an example, an EV vehicle brings together mechanical structures, high-voltage electrical systems, electronics, embedded software, communications, user interfaces, testing, suppliers, and regulatory requirements. The Scrum team may be self-managing in how it executes the work, but it still operates within engineering standards, safety requirements, architecture constraints, budgets, timelines, and organizational commitments. That is where Agile governance becomes important. As shown in this image, governance creates guardrails around the team through technical integrity, safety and compliance, delivery coordination, and organizational alignment. The purpose is not to supervise every engineer. The purpose is to give the team enough freedom to move quickly while preventing local decisions from creating larger system-level problems. Good governance supports autonomy, protects the product, and helps the team deliver safely and effectively. Traditional governance can easily become approval-heavy, hierarchical, and slow. Agile governance should work differently. Leadership defines the boundaries, standards, decision rights, and escalation mechanisms, while the Scrum team decides how to execute the work within those guardrails. For example, an engineering lead may define the approved vehicle architecture or interface standards. Quality may define the mandatory verification evidence required before work is considered complete. Management may define program milestones, budgets, or customer commitments. These roles provide direction and protection, but they should not normally decide which engineer performs each sprint task. That responsibility remains with the developers, in discussion with the Scrum Master, who plan and organize the work needed to achieve the sprint goal. In short, governance sets the road and the guardrails, while the team decides how to drive toward the product goal. Agile governance works through a support ecosystem, where each role contributes something different to successful delivery. Engineering leads provide technical authority and engineering standards, while systems engineers protect architecture, interfaces, and requirements consistency. Project managers coordinate dependencies, milestones, and external commitments. Quality ensures that required processes, evidence, and compliance expectations are met. Verification and validation teams confirm that the integrated product performs as required. SCM supports supplier readiness, procurement, availability, and external dependencies. Management provides organizational priorities, resources, and escalation support. These roles are important stakeholders around the Scrum team, but they do not automatically become members of the team or owners of sprint execution. A key idea in Agile governance is the difference between technical authority and task assignment. An engineering lead may have the authority to state that a high-voltage design must meet a specific safety requirement. However, that does not mean the engineering lead should assign every task to individual engineers. Stakeholders provide requirements, constraints, feedback, and organizational context. The Scrum team still remains accountable for planning the work and executing the sprint. Escalation becomes necessary only when the team faces something outside its authority, such as an architecture conflict, a major safety risk, an unavailable supplier, a resource constraint, an unresolved cross-team dependency, or a customer commitment that needs management action. The escalation path then moves through the team, the Scrum Master or product owner, the engineering lead or project manager, and finally management when needed. The purpose of this path is not to take ownership away from the team. The purpose is to remove blockers, clarify decisions, and help the team continue delivering within the right guardrails. Agile governance therefore sets direction and boundaries, while the team retains ownership of execution. This brings us to the end of Part 2, Teams and Roles. In this part, we explored the Scrum team and the importance of working together toward a shared goal. We looked at product ownership, Scrum leadership, engineering accountability, and Agile governance. Thank you everyone for attending, and we hope you enjoyed this training. See you in the next video.